This lesson looks at multiplying and dividing fractions. I think this is easier than adding and subtracting fractions because you actually don't need to make a common denominator. So that will make your life a lot easier. So we're going to be happy doing these examples. So let's see some examples with multiplying fractions. When you multiply fractions, it's pretty straightforward. All you do is you multiply straight across the top and straight across the bottom. So I have 2 times 5 over 7 times 8, and then I should always reduce my answer in the end if I can. So 2 times 5 is 10, over 7 times 8 is 56. And then remember I should reduce my answer, so I know that 10 and 56 have a common factor of 2, so I can divide both the top and the bottom here by 2 to reduce this fraction. Again, I'm keeping the fraction equivalent when I divide both the top and the bottom by the same number, just as when I multiply the numerator and denominator by the same number. So 10 divided by 2 is 5, over 56 divided by 2 is 28, and then that's as low as I can reduce it. So my answer is 5 over 28. In the second example, it's the same numbers as the first example, and because I want to show you the method of cross-canceling, so it's probably in your best interest to cross-cancel if you can before multiplying across the top and across the bottom, because then it saves you from having to do this step in the middle of reducing. So it keeps your numbers small when you're multiplying. So if I look here, in order to cross-cancel, also here in the second example I've removed the multiplication sign, which now at this stage will be removed most of the time, and you'll see multiplication written like this. So I still have 2 over 7 times 5 over 8, but with cross-canceling I'm going to look diagonally and see if the fact 2 and 8 have common factors, and if 5 and 7 have common factors. Well, I know 5 and 7 don't have common factors, they're both prime, but 2 and 8 do. So I can divide both 2 and 8 by 2, and I can reduce my fractions before I even multiply. So when I do that, 2 divided by 2 will become a 1, and 8 divided by 2 will become 4. So I've reduced my fractions, so now I have 1/7 times 5/4. And now I multiply straight across the top and straight across the bottom, just as I did before. So 1 times 5 is 5, and 7 times 4 is 28. So you see that I end up getting the same thing in both questions, but the second example rather, I cross-canceled, which made my numbers smaller to work with and saved me from having to try to figure out a common factor in the end. Sometimes your numbers might get larger and it might be more difficult to figure out a common factor at this stage. So we'll use cross-canceling from now on. So now in the next example I have negative 1/6 times negative 3/4. So you should also remember from your integer rules that a negative times a negative will give you a positive answer in the end. So I know my answer will be positive. And then I'm looking for cross-canceling again. So 1 and 4, well, I can divide them both by 1, but that doesn't change anything, so I'll just leave that. And then 3 and 6. I can divide both 3 and 6 by a 3. So 3 divided by 3 is 1, 6 divided by 3 is 2. So now I have 1 times 1, which is 1, over 2 times 4, which is 8. So my answer is positive 1/8. Okay, and then the last example, I have 9/10 times negative 3/5. So again, I'm looking to see if I can cross-cancel. So 9 and 5, those don't have any common factors. I can't reduce that. 10 and 3, those don't have any common factors as well, so I can't reduce that. So now I'm just multiplying straight across the top and straight across the bottom. There's nothing else I can do. And I should note as well I have a positive times a negative, so I know my answer will be negative. 9 times 3 is 27, over 10 times 5, which is 50. So that's that. And now let's look at some division examples. So division works similarly to multiplication, just there's one little trick. So when I'm dividing fractions, what I want to do is I want to keep the first fraction the same and then take the reciprocal or the flip of the second fraction and multiply. So for this example, I'll have 2 over 7 times 7 over 6. So I'll change the second fraction here. I took the reciprocal of it, so I flipped it and I changed my sign to multiplication. So now I have 2 over 7 times 7 over 6. So now I want to see, can I cross-cancel? I can. So I have 2 and 6 have common factors. I can divide them both by a 2, so that'll leave me with a 1 and a 3. And then 7 and 7 I can divide both by 7, so that'll leave me with a 1 and a 1. So now I have 1 over 1 times 1 over 3, which will just be 1 over 3. So you see that saves you a lot of reducing in the end. The next example, I have 9 over 4 divided by 6. So again, I'm going to leave out that division symbol. You often will see division written like this. So it's the same thing as 9 quarters divided by 6. So again, I need to flip the second fraction, or in this case, the bottom fraction. I have to also recall that all whole numbers always have a denominator of 1. So now when I flip that second fraction, I have 9 quarters, and then it's going to be times 1 over 6. So I flipped this guy to 1 over 6. And now I look, can I cross cancel? Yes, 9 and 6 have common factor of 3. So I can divide them both by 3. So when I do that, 9 divided by 3 is 3. 6 divided by 3 is 2. And now I multiply straight across the top and straight across the bottom. So I have 3 times 1, which is 3, over 4 times 2, which is 8. Okay, and that's my final answer, and it's reduced. And in the last example, I have a negative 3 halves divided by a positive 1/3. So again, I have a negative divided by a positive, so I know my answer should be negative. And what I'm going to do is I'm going to multiply by the reciprocal of the bottom fraction. So if I want to write that out the long way, I have negative 3 halves times 3 over 1. And then I'm looking at cross-canceling. Do 3 and 2 have any common factors? No. 3 and 1, well, 1, but that doesn't change anything. So now I just multiply straight across the top and straight across the bottom. So I have a negative times a positive, so I know my answer is negative. Now I have 3 times 3 is 9, over 2 times 1 is 2. And that's that. Thanks for watching.